Hi guys. Hope you're having a good day. Hope you're being good for Mrs. Wabi. Your lesson today is assignment 3 point or lesson 3.2, page 180. This is page 180 if you want to follow in your book, but I'll show it here. All right. And so a lot of what you're going to learn in the lesson today is exactly what we did in the GeoGebra lab on Tuesday. So watch how all this plays together. Remember, in the lab, we made sure our lines were parallel lines cut by the transversal. So when we did the lesson on Tuesday, we didn't talk about parallel lines. We just said any two lines cut by another line, that other line is the transversal. But a lot of special stuff happens when they're parallel lines, and then we cut through with a transversal. All those special pairs of angles that we talked about on Tuesday now end up having a special relationship. And as you did the measurement and recorded them in your chart, you probably saw that all the angles either have one number or one measure. 4 of them had one measure, 4 of them had another measure, and those two measures together are supplementary. They added to 180. So here's where we go. If we look, first of all, this is a corresponding angles postulate. So this is not something we prove. This is just something we believe to be true. And it says if two parallel lines are cut by a transversal, then each pair of corresponding angles is going to be congruent. So remember, your corresponding angles, those are angles that are in the same position in the different intersections. So angle 1 is in the upper left of this intersection. Angle 3 is the upper left of this intersection. So 1 and 3 are congruent now. Corresponding angles are congruent. Well, I have 4 different pairs of corresponding angles. 2 and 4 are corresponding angles. Those 2 angles are congruent. 8 and 6 are corresponding angles. They're congruent. 7 and 5 are corresponding angles. They're congruent. But now here's where it really gets fun. Take a look at this. We just said 1 and 3 are congruent. But 1 and 7 are vertical angles, and we know vertical angles are always congruent. By transitive property then, 1 is congruent to 7, 1 is congruent to 3, so by transitive property, 3 and 7 are congruent. Well, what kind of angles are 3 and 7? They're alternate interiors. So alternate interior angles are always congruent. All right, well, all kinds of other stuff is going to happen. Let's just leave it there for a moment, and let's just look at this example. Again, using corresponding angles postulate, back to corresponding angles. So it says in this figure, if the measure of angle 5, that's down here, is 72 degrees, find the measure of, first of all, angle 4. Well, 5 and 4, sure enough, they're corresponding. So if 5 is 72 degrees, 4 is 72 degrees. Then it says find the measure of angle 2. Well, let's see. 5 is here. 4 is congruent. 4 is 72. And 4 and 2 are verticals. Ah, sure enough. 4 and 2 are congruent. This was 5 was 72. 4 is 72. So 2 is 72. Okay, so all these things start to come together. Using the same picture, it says, let's just do it this way. What if angle 8 was 105 degrees? Here's angle 8, 105 degrees. Instead of doing this, let's do this. Tell me all the other angles in this picture then that will have a measure of 105 degrees. Well, I know 8 and its corresponding angle, number 1, are also going to be 105. 8 and 6 are verticals, so 6 is 105. 1 and 3 are verticals, so 3 is 105. Oh, sure enough, and look at this, 3 and 6 are corresponding. Of course they have the same measure, they're congruent. Makes sense that they're 105. But watch this. If 8 is 105, 7 and 8 are a linear pair. That means together they add up to 180. Well, if this is 105, 180 minus 105 means 7 is 75 degrees. Well, 7 is 75 degrees. 5 is its vertical. It's also 75. 75 for 7. 2 is its corresponding, so 2 will be 75 degrees. And 2 and 4 are vertical, so 4 is 75 degrees. All right, so let's see. We said 8 and 1 and 3 and 6 are all 105s. 7 and 5 and 4 and 2 are all 75s. If you give me the measure, or if I give you the measure of just one angle, when I have parallel lines cut by a transversal, if I know one angle, I can figure out all 8 of these angles. All right, so that's pretty exciting. Let's look at some of the other theorems then that come from this. I mentioned this the other day, that on Tuesday, that all of these special pairs of angles that we talked about have a theorem that tells how they're related. So alternate interior angles 1 and 3 are going to be congruent. 1 and its corresponding out here are congruent, and this angle and 3 are verticals. So by transitive property, this is congruent to this one out here. It's not numbered, but this angle. 3 is congruent to that angle. So by transitive property, 1 and 3 alternate interior angles will be congruent. Consecutive interior angles. Remember, consecutive interiors are like 1 and 2. They aren't congruent. They are supplementary. Okay, 1 and 2 are supplementary. 3 and 4 are another pair of consecutive interior angles. They are supplementary, meaning their measures add up to 180. Alternate exterior angles, what do you think? Congruent or supplementary? Well, 8 and 6 are a pair of alternate exterior angles. 8 and its vertical here are going to be congruent. This vertical and 6 are going to be corresponding, and so by transitive property, this is congruent to 8, this is congruent to 6, so 8 and 6 are congruent. The other pair of alternate exterior angles here are 5 and 7. They are congruent. All right, so the cool thing about parallel lines cut by transversal, only one of two things are going to happen. Either angles are going to be, angle pairs are either going to be congruent or they're going to be supplementary. That's the only two things that can ever happen when you have parallel lines cut by a transversal. This is just the proof of the alternate interior angles theorem. I think one of the reasons they put the proof here, and I kind of talked through like in paragraph proof form, why this happens. Most of it's usually by transitive property. See, transitive property. So by transitive property, that usually happens. Alternate interior angles is one of the theorems that gets used a lot. So much, in fact, that we abbreviate it when I write out my reasons, and I'm going to use alternate interior angles. We often abbreviate it AIA for alternate interior angles. Okay, down here, the real world problem, it says Reading Avenue, or Reading Lane, excuse me, which is this one, and Creek Road, which is this one, are parallel streets. And they intersect this Park Road, or Park Road, I would say, intersects them. Park Road would be the transversal. It says if the measure of angle 1 right here is 118, find the measure of angle 2. Well, what's the relationship between 1 and 2? Are they corresponding, alternate interiors, alternate exteriors, or consecutive interiors? Well, they're alternate interiors, so they are congruent. So if 1 is 118, angle 2 is 118. Okay, down here it says, well, same picture, but let's do a different situation. If angle 1 was 100 degrees, oh, what's the measure of angle 4? Well, we already said 1 and 2 have to be congruent. So if 1 is 100, 2 is congruent. 2 is 100. And then 2 and 4 make a linear pair. So 100 here means 4 is 80. Okay, different situation. This time, angle 3. Suppose angle 3 was 70 degrees. What's angle 4? Oh, you know what? I recognize this. Angle 3 and 4 are alternate exterior angles. Alternate exteriors are congruent. If 3 is 70 degrees, 4 is 70 degrees. Okay, so almost always our angle pairs are going to be congruent. The only ones that are special are four special kinds of pairs of angles are the consecutive interiors. So consecutive interiors, it would be like this one and this one. Consecutive interiors are supplementary. Otherwise, your corresponding are congruent, your alternate interiors are congruent, your alternate exteriors are congruent. Okay, well, the fun begins when instead of just giving you outright what the angle is, let's throw in some algebra. So in this case, it says the measure of angle 4 is 2x minus 17. The measure of angle 1 is 85. So now in order to find x, we're going to have to figure out what's the relationship between angle 1 and angle 4. Are they congruent or are they supplementary? Well, 1 and 4 are one of those rare pairs that don't have a special named relationship. But I do know this. 1 and 3 are congruent because they're vertical. 3 and 4 are consecutive interiors. 3 and 4 are supplementary. So 3 has the same measure as 1. So 3 is 85. Together they add up to 180. So that means 4 must be 95. So this 2x minus 17 equal 95. And now I use my algebra to find x. Okay, so I'm looking for what's the relationship. I don't have a direct relationship between 1 and 4, but I can do like 1 and 3. They're vertical, so they're congruent. 3 and 4 are consecutive interiors. Or, you know, I have lots of options. 1 and 7 are corresponding, they're congruent. So 7 is 85 degrees. 7 and 4 are a linear pair. Add up to 180, are supplementary. So again, 180 minus the 85 is 95. This 2x minus 17 equal 95. Now your book did it just a little bit different. They recognize the vertical angle here, 85. They recognize the corresponding or the consecutive interiors here being supplementary, and they just did a substitution. They said, well, angle 3 we know is 85 because it's congruent to angle 1. And angle 4 is 2x minus 17, and when I add them together, I get 180. Then they combine like terms here and so on. They got the same answer. They're going to get the same answer for x. Okay, different situation. We're going to use the same picture, but different situation. This time, it says if the measure of angle 3 is this 4y plus 30, the measure of angle 7 is this thing, find y. Okay, well, let's see. 3 and 7, do they have a special relationship? Sure, they are alternate interior angles. Well, what do I know about alternate interiors? Are they congruent or supplementary? They're congruent. So this 4y plus 30 has to equal this 7y plus 6. That's what they did down here. And from there, it's just a matter of using the algebra. Okay, so the key is you have to know how to set up your equation. Are you going to add the two together to get 180 and solve for your variable? Or are you going to set them equal to each other because they're congruent and solve for your variable? All right, we're not going to do that one because I want to get to this. All of this leads us to the last step of the lab that we did on Tuesday, where we set the transversal to make a right angle with one of our lines, and then found the measures. And what did we find out? Well, if this is 90, this is 90, this is 90, this is 90, 4 90s here, but because of corresponding angles, this is 90, this is 90, this is 90, this is 90. So the two lines are perpendicular down here too. We set it up so I'd make a right angle and be perpendicular here, but then the other line becomes perpendicular as well. And that's what this theorem says. In a plane, if a line is perpendicular to one of the two parallel lines, then it's going to be perpendicular to the other. And we call that the perpendicular transversal theorem. The transversal is perpendicular to one parallel line, so it's perpendicular to the other parallel line. All right, and that brings us to the homework. So I'm not going to go through homework problems with you. I'm going to let you work on that on your own, but that should do it. Remember, tomorrow for your Friday quiz, you will not Zoom. You'll go right to Schoology, open up your Friday quiz, submit it into the Dropbox. Okay, you guys have a good rest of your week and a good weekend, and I can't wait to see you next week on Tuesday. Bye.